All right, this one is going to be slightly easier because you don't have to do an F test on this one, or like you don't have to check if the variances are the same. Okay. Well, it's funny, Olivia. Okay, I missed it. All right, let's see. So. All right, so we're going to see if let's see if a technology program made a difference in test scores. Okay, we're going to assess whether the technology program 7000 has a significant effect on students' computer skills. Okay, we want to see, we give them pre-test, post-test, and we want to see if that made a difference. All right, so we go to data analysis. Let's see, where is it? Okay, t-test paired two sample for means. Okay, it's a paired one. T-test paired. Okay, click OK. And then click on the first variable is the pre-test. Press enter. The second one is the post-test. All right, we're going to put the output range here. Press enter. Click OK. All right, there we go. There's the analysis. All right. Let me make this bigger. All right. You tell me, look at the analysis. Look at the analysis. We're using the criteria 0.05, two-tailed 0.05. Are these two averages statistically significantly different from each other? This is not wine, by the way. It's just grape juice. Make sure I'm making sense. What this means, all right, less than 0.05. What it means is that the likelihood, all right, so you can repeat after me if you want, and just start and just like, so it'll, you could at least practice vocalizing it or verbally saying it. It says the likelihood, the chances of these average differences happening by chance, happening by coincidence, happening because of the luck of the draw, because you were it just happened, okay, is less than 5%. All right, that's what it means. That's what it means. Yes. All right. It's an interesting statistical concept. All right. Go back to being a detective. You're being a detective. You're trying to rule out suspects for these differences. That's what we are. That's what we're doing here. We know there's a difference between these two averages. We know. But what are the chances of these differences just happening by chance? All right, well, let me give you another example. The differences between these two values happening by chance, because we do calculations here. We're doing calculations. It's less than 0.05%. All right. In other words, as detectives, we're ruling out the likelihood of chance. being the culprit of these differences. All right. I need you to vocalize what I'm trying to say, because I think when you say it, all right, so this is it. This is less than 0.05%. All right, it's 0.03. The chances of these two averages, the difference between these two averages, occurring by chance is less than 5%. It's actually 0.03%. Therefore, these are statistically significantly different. If it's higher than 5%, it goes above my threshold. Therefore, I'm not declaring them statistically significantly different. So now it's time to report them. All right, I got to report it. Let's see, where do I go? Oh yeah, you have to get the standard deviation. They don't give it to you. So you have to get that. Okay, so I'll just put pretest. Post-test. You could do it in a calculator if you want to, but okay, here we go. I gotta get the standard deviation. std.s for the pretest group. Okay, there it is. And then standard deviation for the post-test group. All right, they're right there. Very similar. All right, I'm going to report my analysis. Okay, so these are statistically significantly different. I'm going to go here. Compared, okay, so pretest average was 58.14 or 15, whatever. Okay, the post-test was 60.44 average. Pre-test mean, I'll put it there again, 58.15. Standard deviation, I just calculated it. Pre-test, 15.35. The post-test mean is 60.44. Standard deviation, so it's listed on the bottom, 15.99. There was a significant increase from the pre-test to the post-test was found. They put degrees of freedom. Degrees of freedom is right there, 33. T-value, negative 2.15. Yeah, that's interesting. Okay, p-value. We could work on the t-value, the t-statistic to make it positive, but that's, I'll tell you that more later. But okay, t-value is less than 0.05. Less than 0.05. Because which is the case, less than 0.05. Okay, so that's how you report the findings. Any questions? I know we're toward the end of the class, but any questions? All right, hopefully it makes sense. Remember, we're doing the pre-test post-test. So we did it in intervention. All right, there was like technology class. We gave them a pre-test. They scored an average of 58 on the pre-test. Okay, then we gave them this special technology training. All right, it's supposed to technology 7,000 training. All right, we gave them this training. Then we gave them the same test at the end of the class or at the end of the training, and they scored an average of 60.44. So now you could say, oh, there's a difference. But any person, let's say any critic can tell you, oh, that could have happened by coincidence. You were just lucky. You were just lucky. And say you like, really? Is that what you're telling me? I was just lucky. I'm going to perform a 2-paired sample hypothesis test, and I'm going to prove you wrong, mister. And then you do that, you perform the test, you get a p-value of 0.03, which means that the chances of these differences occurring by chance was less than 0.05. And then you prove that guy wrong. You see, I told you this did not happen by coincidence. There was something about that training program that made a difference. That's why these people got higher averages. So you got moted. So that's how you can prove to people that this training program made a difference. All right.